So let's look at our first example. Using the vector shown, determine the magnitude of vector u, the direction of vector u, express the angle with respect to the positive x-axis, the true bearing of u, and the expression of u in polar form. Okay, so we have a diagram here with theta, the vector u, and our point 3, -5, so its coordinate. So I'm going to write in or draw in my right angle triangle. This is 3, this is 5. Now we need to know our magnitude and we need to know the theta. So let's do that first. So for magnitude, that's our R. The magnitude of u. Now that's equal to the square root of 3 squared plus 5 squared, just using Pythag. So the square root of 9 plus 25, which is the square root of 34. We're going to leave it as its exact value. Now for our angle, we've got hypotenuse, we've got opposite and adjacent. So tan theta is opposite over adjacent. Now you should realize, or you'll just get into the habit, it's also on your formula sheet, that it's just theta equals the inverse tan of y over x. So you can go straight to that if you want, or you can just rely on doing the trig like you normally would. So opposite over adjacent is 5 over 3, so theta is inverse tan of 5 over 3. And that's approximately 59.04 degrees. Again, with the formula, if you look at your formula sheet, it does have that r equals the square root of x squared plus y squared on it. So you can go directly and use those formulas if you want. I'm just trying to, as we're starting out, keep it based in what we know with trig. So let's start answering our questions. Part A, our magnitude of our vector was the square root of 34. It's a magnitude, so I'm going to write units. B, the direction of our vector. Now it says express the angle with respect to the positive x-axis. We are in the fourth quadrant, so our angle with the positive x-axis is going to be 360 minus theta. So 360 minus 59.04, which is approximately 300.96. Part C, the true bearing. Now hopefully you remember your bearings, but if not, true bearing is in a clockwise direction from north. Okay, so that's our true bearing. So when we think about this question, we have that this angle here is 59.04 degrees. Our true bearing is that angle there. So our bearing is going to be 90 plus 59.04 degrees, which is approximately 149.04 degrees true. Part D, our polar form for our vector is our magnitude, square root of 34, and then our angle, which is 300.96 degrees. You could also have square root of 34 and express that angle as the negative, so negative 59.04 degrees.